Hello, hello. Good morning, good afternoon, and good evening wherever you are. This is the SNIA NSF webcast about xPU deployment and solutions, a deep dive. I am your host, John Kim, chair of the SNIA NSF, our Networking Storage Forum, and I'm delighted to host a distinguished panel of experts for you today to talk about xPU deployment and solutions. So let's go ahead and get started. Today's presenters are, well, as I mentioned, I'm the chair of the SNIA Networking Storage Forum, but we have, more importantly, Tim Michels, distinguished engineer from F5, Mario Baldi, fellow at AMD Pensando Systems, and Amit Radzi, software architect at NeuReality. These three experts are going to tell you where to deploy, how to deploy, and when, where, and how to deploy xPUs. But before we get into that, let me cover a little bit about SNIA and the NSF. So SNIA is, of course, a Storage Networking Industry Association, or the Storage Networking Industry Association, with more than 180 organizational members, more than 2,500 individuals contributing, and more than 50,000 total members. We focus on specifically in the Networking Storage Forum, we focus on different storage connectivity and networking technologies, different storage protocols, storage architectures, including virtualized, hyperconverged, and software-defined storage, storage protocols, and ways to secure data, among other things. And obviously, we're also covering xPUs. But before we dive more into that, a brief legal notice and disclaimer. I won't read every line on the slide, but keep in mind that this material is copyrighted by SNIA unless otherwise noted. Member companies may use this material under the following conditions that are listed here. This is a SNIA project, and keep in mind that neither the author nor the presenter nor the chair, the moderator, myself, none of us are attorneys, and nothing in this presentation should be construed as legal advice or the opinion of legal counsel. This does represent our personal opinions and our current understanding, which we believe to be accurate, as far as accurate as we can make it, but we do not assume any responsibility or liability for damages arising out of reliance on this information. No warranties are on this information. Okay, we've kept the attorneys happy, so I want to let you know that this is the third in a three-part series. Our first webcast covered SmartNICs to xPUs. We talked about what are xPUs, and basically why are more people using them. In the second webcast, we talked about what can be accelerated. You can watch both of these webcasts on demand in the SNIA Educational Library. So today, in the third webcast of our xPU series, we will cover when to deploy xPUs, where to deploy them, and how to deploy them. This is a deep dive getting into the details of xPUs. So first up, I forgot a few more housekeeping items. So if anyone that wants to see the slides are available in the attachments tab of your viewing screen. If you want to see this afterward, it is being recorded and will be available on demand in the SNIA Educational Library, in the SNIA YouTube channel, or on Bright Talk. And finally, please ask your questions. Put your questions in the question Q&A tab, and we will answer them as best we can. If we don't get to any questions, we will publish them in an FAQ after the webcast. That said, Tim Michels of F5, please go ahead. When do we deploy xPUs?
Yeah, hi there. I'm Tim Michels, and I'm here to talk about when to deploy an xPU. And I'd like to preface my follow-on slides here with a few comments that occurred to me as I was reviewing this material yesterday and this morning, is that the context of my material really is tied into the previous presentation, so I hope you've seen those. And if you're a little confused, maybe go back and look at those, because I'm not going to catch you up on those. You'll have to do that on your own. I also use the term xPU in the broadest sense. I'm not talking just about a specific piece of silicon or even a card that silicon might be mounted on. I'm talking about an xPU in a larger sense of an ecosystem of this class of chip, this type of card, this type of system, and the software stack that rides on top of it. So think about xPU in a broader sense when I make my comments about when to deploy this technology. Okay, so I'm going to start off with talking about the the value of an XPU deployment to me is it's going to depend on how you plan to use your XPUs in your data center or your cloud. To me, it breaks out into two ways. There's sort of the incremental or more traditional use case, which is derived from the way performance NICs have been used and are still used today, versus a more revolutionary and forward-looking use case. Dropping down into the incremental use cases, I think most people are familiar with these ideas, that the xPU, like a performance NIC, has a set of hardware acceleration offloads. These offloads are consumed by applications running on the host server in a very tightly coupled fashion. Things like, hey, I need to do some bulk crypto, or hey, I want you to stick this packet in a tunnel. So we're just getting sort of ad hoc piecemeal acceleration, tightly coupled. That's very traditional performance NIC style. Another sort of incremental use case is to take the XPU compute and the cores that are being put onto these XPUs and not really using them in a new way, but sort of keeping them in their old role. Performance NICs have always had a few cores laying around. They're used for control plane, configuration management, and even the occasional exception processing when something falls out of a hardware offload because it's an IP frag or a similar situation. Using your XPU compute in that way is very traditional, very incremental. There's not a lot of revolutionary content there. And then finally, if your XPU comes with a closed software stack, so you bought your XPU card from a vendor, that vendor gives you all of the software that goes on that XPU, and the only way to consume those cores and the capabilities of the XPU are through an SDK that's accessed by an application running on the host server. Again, that's a very traditional performance NIC use case. Can you get value out of an XPU that way? For sure. Is it going to unlock, the future and the way that we see, or at least I see, data center and cloud development trending, and the way the paths that are being pioneered by hyperscalers? No, I think you need to look at XPU and the investment and the ROI that one can capture by using XPUs. You need to look at using them in a much more revolutionary way. So let's look at what that means. So that means viewing your XPU as a hosting platform, and that it's capable and ready to host complete standalone infrastructure services. So you're not just moving a bulk crypto process, you're moving the entire crypto stack, including key exchanges. You're not just moving a storage process, you're moving the entire storage stack, or the virtualization stack, or the security stack. Another element that is revolutionary in XPUs is that because you're moving stacks, this is a great time to look at the APIs, the way that infrastructure services connect to applications, the way that infrastructure services connect to their hardware offloads, and create some abstraction and some normalization of those APIs. And by doing that, we can start to imagine that infrastructure services become much more portable and mobile and composable across the cloud infrastructure. A third component that might be revolutionary is that once we've sort of moved the entire infrastructure service stack off of the host server and decoupled it from the locally hosted application, there's no reason, and in fact, there's lots of reasons that we should go the other way and think about making that infrastructure service broadly available, not only to the locally hosted application, but to any application available in the local network. So this essentially is creating multiple application services. If you have a firewall, for instance, that stood up in front of a locally hosted application, but that firewall is used at, say, 10%, there's no reason that firewall can't also be handling data for other applications on other COTS servers that are hosted nearby. Finally, is this idea that if we can view the software stack that's on the XPU as essentially being a PaaS or platform as a service layer that comes with my XPU, or perhaps I install it in my XPU. Once I have that stack in place, now I'm capable of hosting any kind of infrastructure service I want on my XPU. These might be services that I, as the cloud creator, have written for myself for my particular needs. And more likely, I'm able to go choose best of breed services from ISVs in the marketplace and assemble those really into a composable and a very customized deployment that suits my needs and is very fungible into the future as I see my needs change and I see my scale requirements move up and down. Stepping into my next slide, I want to push a little deeper into the value of deploying DPUs in order to get this separation between the business application and the infrastructure service. You see I have it sort of depicted there in the diagram on the left. The business applications are running on the host OS. That's on the host server. I've moved my infrastructure service stacks for network, storage, security, and even virtualization down onto my xPU. And you might question why to do this. There's lots of reasons to do it. One reason is the hyperscalers are doing it. And if Amazon's doing this and Microsoft Azure is doing this and Google GCP is doing this, maybe the rest of the industry should pay attention to why they're doing it. And they're doing it because there's lots of benefits. One of the biggest benefits is to get this separation of the performance requirements, to get the infrastructure compute requirements out of the way of the application compute requirements. There was a statement made in an NVIDIA GTC in 2020 where it was pointed out by Jensen that 30% of CPU cores, and this was in 2020, 30% of CPU cores in a cloud deployment were being consumed just by the infrastructure and were not available to the business applications that the cloud was created for. And he projected that as connectivity to those servers goes above 100 gigabits, we could see that go into the hundreds of cores being required. I think that might be a bit of hyperbole, but you can see what's going on there. And this further evidence was provided by Meta this March at a presentation where they showed one of their ML applications where the workload here is in the gray and the infrastructure services that sit in front of it are in the orange, and that as they increased their cluster size, they saw that the infrastructure workload came to dominate the overall compute picture, sort of an Amdahl's law applied to clustering and infrastructure services. This is not a good thing. This is not sustainable. xPUs used properly and in a revolutionary way can really help to address this. Okay, so when we deploy xPU technology, what do we get? This leads into when do we deploy? We need to deploy when we need these benefits. So I've called out here 4 main benefits. I have the one on the left, application simplification, that sort of stands on its own. The other 3 I've grouped together as collectively as service isolation within the infrastructure layer, with the 3 pillars of this isolation being performance, security, and organizational. So a quick click down into each of these boxes. The application simplification comes back to this idea that if you've moved your infrastructure services into the xPU and you present the application with a very simple, straightforward, and standardized API, something like VirtIO Net or VirtIO Block for network or storage, these are well known, well established, widely available APIs in order to access those infrastructure components. That makes your application much simpler, and your application developer can focus on the business logic and not on how to get on top of a piece of particular hardware. Effectively, we're abstracting the application away from the infrastructure and its complexity, and we're pushing that complexity and the complexity of the associated services down onto the xPU and away from the application. This makes your application more simple and more portable. Moving over to performance isolation, we touched on this earlier. This is the noisy neighbor problem of infrastructure workloads scaling up or down, getting in the way of the business workloads scaling up or down. By pushing all of the infrastructure workload to the xPU, we free up all of the cores for the business applications. This makes planning and provisioning much simpler when you're scaling your cloud, and it makes those cores that are on those servers completely available for monetization, whether you're selling compute to external customers or whether you're selling it through virtual monetization to your internal customers. And finally, it makes the ability to plan and deliver SLAs. This is particularly interesting in telco environments. You're able to stand up these SLA contracts and actually realize them with a high degree of confidence because the noisy neighbor problem isn't in the mix messing things up. Clicking over to security isolation, this is the idea that we can confine a blast radius. If we have an exploit in the business application, it cannot get into our infrastructure. Likewise, if something in the infrastructure were to be compromised, it cannot get into the business application. So we can confine the reach and the range of the damage. If we use the xPU to do virtualization control as well, this is the concept of putting your hypervisor control essentially on your xPU, standing up a hypervisor agent on the server that manipulates the CPU registers, but it only talks to your hypervisor control point on the xPU. You essentially can air gap your hypervisor because the hypervisor control point is no longer on the host compute. It's no longer subject to side channel attacks. It's no longer subject to privilege escalation. Its security metadata is no longer visible to any sort of compromised business application that might be trying to run there. And this completely protects your, not only the hypervisor and the infrastructure, it protects the other business applications as well. And the third point here is that we can create a defensible barrier for application security metadata. These are the certificates, these are the keys, these are the things that we need to ensure privacy and authenticity and authorization. If we stand these up in sort of an HSM that's deployed on the xPU, we have a very secure place. We have a vault on the xPU that's very hard to reach from the host server or from the network. And we make these available in secure ways to the application and only the application that needs to see its particular keys, and it can't see or touch the keys that are for the other applications or that are for the infrastructure. My final box here is organizational isolation. I think this is something that's very important that very few people talk about. It's this idea of separation of concerns and how this impacts the way a business is structured. Traditionally, in 2-tier and 3-tier data centers, we had this very nice breakdown of boxes for NetOps people, boxes for SecOps people, and then we had the servers that the DevOps people deployed on, and it kept those organizations within their zones. They knew what they controlled. Things functioned pretty smoothly. When we virtualized everything and we threw all of those pieces together onto a single server, those lines broke down, and it caused an organizational breakdown and a lot of friction. By moving infrastructure services back on the xPUs, we can get back that sort of alignment between the way the business is managed and the topology of the data center and the cloud. We can stand up a Kubernetes cluster, for instance, to manage the deployment of our infrastructure services, while we have completely different Kubernetes clusters that the DevOps teams are running to manage the deployment of their business applications. And it brings us back to that previous era that worked so well. And then the final point here is this isolation of the infrastructure from the business app leads to a much easier path to compliance, whether you're chasing PCI compliance or FIPS compliance or whatever kind of security compliance you're trying to get to. By having bright lines, secure paths of control, you're much easier able to demonstrate that you are in compliance and achieve that certification. All right, jumping into my last slide here. I think when you look at when to deploy DPUs, you need to look across, what are the risks, what are the rewards here? So there clearly are some things to be cautious and aware about when thinking about deploying DPUs. XPUs at a base element. These XPUs are going to skew at the high end of the performance NIC market for any of these vendors, right? If not absolutely at the highest end. So if you're thinking of rolling out lots of servers with XPUs in them, you're going to see your CapEx costs of that deployment are going to be higher than they have been in the past. Per server power is also going to skew higher. Again, these cards are at the high end of the silicon content. They're at the high end of the clock rate. We're asking them to do a lot now with hard rough loads plus compute. So they're going to take a lot of power. And that's going to lead to impacts on what kind of servers we can use. We're going to need flyover cables to provide additional power. We're going to need cooling systems in those servers. There might be height and length requirements that affect your server selection. So no, you can't just jam any XPU in any server. You're going to have to match your XPU choices with your server choices. Deployment complexity. Really now we're deploying two sort of separate systems, the XPU systems and then the server systems, and the way they're joined together and how we get them organized onto the network and how we do discovery and provisioning and deployment. All these have to be figured out. We need tooling to do that. We need some education. We need some engineering. It's all complexity. It's not free. And then finally, the application refactoring comes back to this idea that we normalize applications to very standard and simpler APIs, but not all applications are there today. Not everybody chose the same storage access. Not everybody chose the same networking access. you might have to go back through your application inventory and refactor parts of it in order to get that normalization. But if we can get through those hurdles, we can get to the payoff, right? The payoff of normalized application APIs is that now your applications are simpler and they're much more portable. You can move that application around across all of your infrastructure without any changes to it. Potentially, you can move it into hybrid clouds, into colo spaces, or maybe even to the public clouds as they adopt similar APIs. We get enhanced portability, not only of the application, we get portability of the infrastructure service, assuming that the xPU community, which it's working hard to do today, can generate a set of standardized APIs for not only talking to applications, but for talking to hardware offloads across any of the xPU vendors' silicon. That leads us to composable infrastructure, this ability to pull in the infrastructure services we need, assemble those into groups, stand those up in front of applications, scale them up and down as needed in a very composable and flexible way. We get dramatically increased scalability. Why? Because we've taken the infrastructure service now, put it very close to its hardware offloads, and given it dedicated compute, and basically cleared all the smoke out of its domain so that it can do its job in the way that it knows how. And we can scale the performance across multiple XPUs. We can make that XPU available to multiple applications, even on different servers. In all directions of scalability, we get a lot more control than what we have today with performance NICs that are tightly bound only to the local workloads. The enhanced manageability, that ties back to my earlier comments about getting the isolation to allow us to line up our manageability with the way our businesses are organized today. This should lead to lower operational complexity. While we had some deployment complexity, once we're deployed, this ability to see your infrastructure services and see your applications independently, see what's working, see where the bottlenecks are, and get them fixed, and have some observability across the board is going to lower the operational complexity. And you're going to have the right people looking at the right pieces and not being confused by elements that they don't understand. And all of this adds up in the end to the real goal, which is lower TCO. Can we build clouds faster? Can we scale them faster? And can we operate them with less overhead and expense? I think that finishes my comments, John.
Tim, thank you very much. Just one question before we move on. You mentioned how you could use the solution with a hypervisor and isolate the hypervisor. Could xPUs also be deployed if you're doing containers and no hypervisor?
Oh, yes. Yeah. I mean, even a container needs a CNI and a runtime environment, right? So effectively, that is the hypervisor in that scenario.
Excellent. Okay. So, hey, thank you for explaining to us in great detail the positives and negatives or trade-offs of when to deploy. We now turn to Mario Baldi of AMD Pensando to help us understand where to deploy xPUs. Mario?
Thank you, John. Yes. So let's look into where xPUs can be deployed. And we are going to do this at different levels. First of all, at a very macro level, we look at different market segments, and the kind of applications we want to use the DPUs, the xPUs for. And then we look at where to deploy from a topological point of view. Where in the end-to-end system are we going to deploy those xPUs? And finally, where to deploy from a more microscopic way, in the sense of which form factors can xPUs have, and where do we put them, in which system elements are we going to deploy those xPUs? So let's start first of all from high level and look at the deployment opportunities that we have for xPUs. And there are different deployment opportunities in different markets, and each market has its own set of use cases. For example, the first area where we may want to deploy xPUs is the enterprise data center. There we may want to use xPUs for security reasons. For example, we may want to use them to enforce microsegmentation, so the possibility of controlling which hosts can communicate with each other independently of their physical location, not only independently of their physical location, but also independently of the logical IP network they are part of. The traditional firewall model implements security policies between logical IP subnets. The microsegmentation is security policies between any pair of hosts, or even better, any pair of workloads. And then we may want to virtualize storage, so implement storage virtualization within the xPUs versus having it implemented in the CPU. And finally, we see also cases where we have a partial offload of hypervisors in the xPU. So part of the hypervisor is running in the xPU, not only for sure the part that is implementing networking and security services, but not necessarily. Another area, domain in which we may want to use xPUs is the cloud data center. There we are interested in network visualization services, so use the xPU to create overlays and to separate the physical location of workloads with their logical belonging to a virtual private network, virtual private cloud, the network of a specific tenant. We may want to use xPUs to implement security policies and, of course, to virtualize storage. Even more important are xPUs in a situation of colocation or a situation of bare metal as a service, because there we cannot use the CPU to run infrastructure services. In that case, the CPU is completely devoted to the tenant, who is running whatever software they want to run. So in that case, the xPU is the ideal place where to implement those services that in enterprise data center or cloud data center traditionally may be implemented in the operating system, in the hypervisor. Here, we need to offload those services to the xPUs. And there, what are those services? Again, network virtualizations. We want to be able to create overlays so that we can place all of those servers in the appropriate tenant networks, and we want to be able to virtualize storage. And another market where xPUs are being considered is the market of the service providers, and specifically the edge of the service provider network, or the far edge of the service provider network, for example, in 5G deployment, where xPUs are seen as a way of offloading virtualized network functions. Service providers use a network function virtualizations to be able to run traditional network services on x86 processors, but this has proven to be very expensive, very processing power hungry, and not really scalable. So especially in small edge data centers where we do not have availability of a lot of CPU power, it's a good idea to offload at least some parts of those virtualized network functions into xPUs. And finally, xPUs can be effectively deployed in the context of storage providers. So to provide storage virtualization, to offload storage virtualization for storage targets. So in a context in which storage is virtualized, we can use the xPUs to offload the storage protocols at the target, at the storage arrays. Now, from the point of view of the actual topology of our systems, of our end-to-end systems, where exactly do we want to deploy those xPUs? One place that seems really ideal for deploying xPUs is the network edge. And what do I mean by network edge? I mean the point of contact between the host and the network. This seems to be really the sweet spot for XPU deployments. Why is that? First of all, that's a spot where we can easily access traffic. That's a natural spot where to access traffic. Traffic is being sent and received by hosts. So if we place the XPU there at the edge between the network and the host, we can access all the traffic, access to be able to observe it, or access it to be able to manipulate it, access to be able to filter it, depending on the kind of applications we want to implement. Moreover, that's where we can possibly have access to the PCIe bus. So if we have access to the PCIe bus, then we can implement a number of services that are accessed by the host processor through the PCIe bus. The typical example is storage. If we want to virtualize storage there, we can show remote drives as if they were locally connected to the PCIe. And finally, by deploying XPUs in this particular spot at the network edge, we can leverage the scale-out model. As data centers grow and more servers are being added, of course, we also add more XPUs, and we naturally scale with the scale of the data center. Now, given that we have said, okay, we want to place that XPU at the edge of at the network edge, but how do we place it there? Which kind of form factors do we have for our XPUs? Well, the first one that comes to mind is the form factor of an adapter, of a PCIe adapter, and specifically a network adapter, so a network interface card. So we can embed our XPUs in network interface cards. Or we can create switches that have XPUs embedded, and we usually call those kind of switches smart switches. Now, in this case, we do not have direct access. The XPUs does not have direct access to the host PCIe. Okay, when we have a smart switch, what we probably want to do is to connect hosts to the smart switch. The advantage is that, compared to the NIC, is that multiple hosts can use the same XPU, which is in the smart switch, but the limitation is that XPU is not directly connected to the PCIe bus, so it cannot offload services that require access to the PCIe bus, like, for example, storage virtualization. Now, however, this doesn't mean that we cannot do it. There are solutions like xEther to remotize the PCIe bus, and in that case, we can remotely offer access, offer the XPU access to the PCIe bus. And another form factor that we can have for XPUs is a form factor in which the XPU is embedded in the motherboard, so is directly attached, for example, to the PCIe bus, but on the motherboard. Or even as we look forward, we can envision having chipsets where you can put together a CPU, a general purpose processor, and an XPU using other technologies other than PCIe, for example, using chiplet kind of technology. And if we have XPUs in all of these form factors, how can we place them at the network edge? Well, we can place them in hosts. And in that case, again, we can use either the NIC form factor, where we plug the XPU on the PCIe bus, or we can use the chipset or motherboard integration form factor to have XPUs directly in the host. And again, because, for example, the XPU is in a network interface card, it's going to be at the edge, in reality, between the host and the network, having control of all of the traffic that goes from the host to the network and vice versa. We can use the NIC form factor also in storage targets, so we can place the XPU there, or in the smart switch form factor, we can place XPUs in the top of the rack, directly connected to servers. And with these, I think I finished my overview on where to deploy XPUs, and I'm going to leave the floor to Amit for how to deploy XPUs.
Mario, before we go to Amit, one question. would there be scenarios where you might deploy in multiple cases? Like, would it make sense to deploy an XPU in the host and in the switch and in the storage?
Well, I would say in the host or smart switch and the storage target, yes. In the host and in the smart switch may be a little bit of an overkill, because you would want to implement your services in one or the other. But you may have situations where, for example, those services are offered by different organizations, and so they use different XPUs, one in the smart switch and one in the host, to deploy those, to implement those services. Or you might have cases in which, for scalability reasons, because you are offering a significant large set of services, they cannot be offered by a single XPUs, and then having two XPUs, one in the host and the other one in the smart switch, can be beneficial.
Okay, that makes sense. So it sounds like it would be the host or the switch most of the time, but you could also do the storage. And in terms of whether you deploy at the edge or in the data center, is that just a question of where the servers are? So you would deploy it wherever the servers are, whether that's edge or core?
Right. You deploy where the servers are, and you may deploy in both places, right? You may have the need to implement infrastructure services in the central data center, and other services at the edge of the network in the edge data center. So, for example, network services in the context of a service provider, network services that are required for the customers that are accessing the network at the edge will be deployed at the network edge, but typical cloud type of services will be in the central data centers, if that service provider is offering also typical services that are typically offered by cloud providers.
Okay, makes perfect sense. Thank you, Mario. Let's go now and learn more about how to deploy XPUs. So Amit Radzi from NeuReality, if you're ready, please go ahead. Tell us, how do we deploy?
Yes, thanks, John. So now that we've seen when and where, let's understand how. So I'll start with a diagram of a disaggregated composable infrastructure, which we've seen multiple times in this series of webcasts. We have general purpose servers connected over the network and consuming resources from a disaggregated resources allocated somewhere along the same network. In these slides, we'll talk about two use cases. One is for remote storage, which has storage drives connected to the network. And the other one is for AI inference, where we consume deep learning compute resources from the network using DLAs, which are deep learning accelerators, which are hardwares which accelerate the deep learning compute. So let's see the steps required in order to deploy it. So the first thing we'll do is we'll map a workflow from a local flow into a disaggregated flow. There could be cases where a flow is already disaggregated, and this step could be skipped, but in a lot of cases, we start with a local flow and then we move to a disaggregated one. So we need to choose a workflow that will benefit from the composable data center. It will benefit from consuming disaggregated resources that are dynamically added. We need to find a well-defined demarcation line between an initiator consuming the resources and the target which is exposing them. We need to have a clear and easy to use API, preferably an existing one. We'll see in the storage use case a good example for that with NVIDIA. We need that demarcation line to allow for virtualization and multi-tenancy. We'll have a disaggregated target, and that will be beneficial when it will be able to serve multiple clients. So we'll need to virtualize the resource and support multiple clients connected to it. And it should also allow for elasticity for adding and removing resources dynamically. So this composable data center is beneficial when you compose, you add and remove resources dynamically whenever the client needs them. So that's the first step of taking a local workflow and mapping it into a disaggregated one using these main goals. And then we want to see how we can accelerate the disaggregated workflow with an xPU. So data-centric tasks like data movement or encryptions or those kind of workloads are immediate candidates for operations that could be done by the xPU. But we will also want to identify bottlenecks, some system bottlenecks that might be in the flow that we can remove by offloading some operations into the xPU. For example, memory bandwidth issues when you are moving data from the xPU to the general purpose server to the hardware and back. Those bottlenecks might have been in the local case, but some of them, even when you're mapping a local to a disaggregated flow, might create different bottlenecks. So that's also something to look for when you are deploying it and seeing how you can accelerate those using the xPU. And additionally, we'll want to identify operations that consume host resources like virtualization or isolation monitoring and such operations that could be offloaded into the xPU and reduce the host overhead. So that's the general flow. Now let's have a look at the two use cases. So the first one is a storage drive. So in this one, in the local case, clients consume the storage drives using NVMe, a local NVMe connected to the PCI. And in the disaggregated flow, they consume the storage using NVMe over Fabric, which, as we stated before, it is the same client API using them, so the migration is very easy. But beneath that, it translates from local PCI NVMe, it translates into NVMe over Fabric and goes over there. And on the target side, we can expose remote storage virtually, different from the actual hardware topology. So we can have a client exposed to one client, an NVMe drive, which is virtual. It could be a partial of a real hardware of SSD, or even multiple ones exposed as a single storage drive. We need to implement the NVMe over Fabric on that remote side, implement the mapping between them, supporting multiple clients, and all the features that are required in order to make the flow disaggregated. So all that logic moves from, will be placed on the server side. And now we'll see how we can accelerate that flow into the xPU. So we'll place xPUs as the network interfaces in both client and server, on both in the initiator side and on the server side. We can also connect the xPU on the server side directly to the storage drive using PCI peer-to-peer. And we'll start offloading the capabilities into the xPU. So on the client side, we can offload the protocol of NVMe over Fabric. We can offload virtualization, multi-tenancy, if on that general purpose server there are multiple clients that need virtualization on their network. All that could be offloaded into the xPU. And on the target side, we can offload the NVMe over Fabric protocol, its entire termination. We can offload more storage offloads like compression, encryption. We can offload the mapping between virtual NVMe drives exposed to the clients and the actual hardware connected there. And if there are no intensive tasks that need to happen on the target side, that depends on the use case and what features that storage drive needs to give. So if there are no intensive tasks like failover or auto mirroring or things like that, we can do a full offload, meaning we can implement everything inside the xPU and that storage drive and eliminate the need for a general purpose server on the target side, which is what Tim referenced as the revolutionary step of the xPUs. All right, so let's go over to the next use case, which is AI inference. So here on the regular, on the local case, a client consumes those resources locally over the PCI using the driver and runtime of the DLA, the Deep Learning Accelerator. On a disaggregated flow, the client consumes those resources using a runtime serving library. The networking protocol is usually REST or gRPC, but it could be other protocols as well, but something very well defined and clear cut. On the server side, we'll need to do parsing of the AI request. We'll need to schedule the hardware resources to the different AI requests that arrive. We'll need to execute the AI inference on the hardware itself, retrieve the results, send it back to clients, and support multi-tenancy and clients, including quality of service, exposing Kubernetes resources or additional monitoring stuff that are very common in the AI inference case. Then we'll see what we can accelerate. So again, we'll place the xPUs both on the client side and on the target side. On the client side, all the virtualization and networking and standard offloads that we discussed are already there. On the target side, we can offload the network protocol itself, including the serving protocol, if that's something that can be done in the xPU. We can offload driving the DLA itself, the hardware from the xPU, if they are connected through the PCI, for example, with peer-to-peer. We can try to offload the resource allocation, the virtualization, quality of service, multi-tenancy. Some of those might be complex, but depending on the features required, those could be done in the xPU. And again, here also, if we could offload everything, if you can implement all the required features of that remote system, which is a bit more complex than the storage one. There's a model serving that needs to be done, Kubernetes, sometimes pre and post processing that the DLA can do, or it can do, or what can be done either in the xPU or DLA. But if everything that is required is encapsulated in both the xPU and the hardware connected to it, we can do a full offload and remove the general purpose server on the target side as well. So let's summarize how do we deploy it. First of all, if we have a local workflow, we need to map it to a disaggregated flow. Once we do that, we need to see what functions we can or we should offload to the xPU, starting from low-hanging fruits like the usual suspects of data-centric, but also looking for system-level bottlenecks and operations that have a high overhead on the host, but are simple enough to be done on the xPU that you are deploying. In partial offload, usually the complex functions will run on the general purpose server. We will offload the functions that we will benefit mostly from to the xPU. Or if the entire flow can be done in both the xPU and its attached hardware, we can do a full offload and remove the general purpose server from the target side. So we saw two use cases here, the storage target and the inference, but there are many more system flows that can be deployed with xPUs. In previous webcasts in this series, we saw a lot of offload functions that can be done from security, networking, general purpose, compute, and everything. All of those in different system flows could be done. So you take a flow, you go over these steps and see if it makes sense to deploy it and go over those steps. And with that, I'll give it back to you, John.
Amit, thank you very much. So I do have some questions for all of you, but just a few reminders again on the housekeeping. We'd like all attendees to rate this webcast, give us your feedback. There's a way to rate this and both in, you can rate us from 1 to 5 stars, as well as give feedback right here in the BrightTalk interface. Reminder that these slides are available now, but will also be available for download in the educational library, and you'll be able to watch a replay of this webcast in the educational library at SNIA, in the SNIA YouTube channel, or on BrightTalk. So, and you can follow us for more information at SNIA NSF on Twitter. So, a couple of questions, Amit. So, you showed an example where using the xPU to accelerate access to a deep learning accelerator and a GPU. Can you talk a little more about, is that a choice, or would some customers deploy one or the other, or deploy both a DLA and a GPU, and then accelerate access with an xPU?
Yeah, so I think that really depends on the use case. I mean, there are a lot of operations that need to be done when you are doing an AI inference service over the network. So today, if the use case is enough, usually I would say that you would put more the GPU and the DLA if you are trying to do a full offload, the entire evolutionary one, and there are some operations that the GPU can't do very well and the xPU can do very well. That's a place to add additional DLAs. But depending on the use case, an xPU and a DLA might be enough, an xPU and a GPU might be enough. But as long as you're trying to achieve more and more features and do that as a full offload and remove the general purpose server, it is more likely that you might need both of them and not just the GPU and the DLA. That, of course, depends on the xPU that you have. I'm assuming the future xPUs will have more and more features, so even that might reduce the use for one of them.
Okay, that makes sense. And one more question specific to you, and then I have some general questions for all of our presenters. You showed that said one of the steps needed is to map the take the local workflow and map it to a disaggregated workflow. Who does that? Is that the end user, or is that the application, the ISV, the software ISV, or is it a system integrator? Who does that mapping to make it disaggregated?
So I assume in most cases that would be, I mean, it depends. If you are in a data center, that would usually be the data center operator, whether it's a cloud operator or if you have your own data center, that will be someone doing that there. And I assume that also the second part of offloading will usually be done by the same person. If the xPU are part of the infrastructure, then the one who's in charge of the infrastructure will do both of them. But there are cases where you can want to disaggregate without using the infrastructure. For example, you can do what we discussed today with AI inference even without xPUs, just using Kubernetes and some runtime server. So that's something that is also done today even without the benefits of xPU by some let's say customers that need it for themselves. So sometimes, usually, if the customers already saw the need for it, it will already be there, and the infrastructure people won't have to do it. They will start from a disaggregated one. But it is easier if you want to use that. You didn't disaggregate it. So if it wasn't already done, it's something that the infrastructure people would do.
Okay, Amit, that makes sense. Now here's a more general question. I think this could be all of you, though maybe it's more for Tim and Mario. If you wanted to deploy, you decided where and when to deploy. How do you work? Who do you talk to in terms of hardware or software, but more on the hardware side to get those xPUs? And do you talk to the xPU vendor, or to the server vendor, or to the service provider running the data center? Thoughts from, and I'll take answers from any of you or all of you. So who do I talk to get the xPUs?
That's a very, very good question. So yeah, and I'm sorry that I took the floor, but I think it's tied a little bit to the where to deploy it, right? Because if the xPU is deployed in a server, then you can talk directly to server vendors. There are several server vendors that sell pre-configured or servers that you can configure as you buy them with an xPU inside. And this is even more true in the moment in which, as far as I know, besides some proprietary solution, I don't think there are commercially available xPUs that are either integrated with CPUs or on the motherboard. But it's my personal guess that at some point we'll see them, and then for sure you'll buy your server with the xPU inside. Of course, when if instead you're gonna buy a smart switch, then it's gonna be more your networking vendor, which could be the same vendor that's selling you the server, but it could also be someone else. Now, one last note. I think it's very interesting that you said, do you go to your cloud provider? Because again, I don't think this is something that's already available, but I would expect that at some point we're going to start seeing xPUs made available in the cloud context, where the xPU is not used by the cloud provider to provide their infrastructure services, but it's going to be offered to the tenant, either an xPU or a slice of an xPU, offered to the tenant to run their services, their apps.
All right, Mario, great point. Tim, any perspective on that? Or you can also talk about, Tim, reflect on the software. If I need to modify my applications, as you talked about, to support this, how do I get those applications updated?
Yeah, I would point out that it's early days, right? This is an emerging ecosystem. We have some open source community efforts going, like the Open Programmable Infrastructure, where we're trying to look at this as a holistic solution. We're trying to get on top of all the xPU vendors' cards. We're trying to define the frameworks for what that software stack on the xPU might look like, and address those API as well as the provisioning and deployment issues. But it's still early days. We're working our way through that. If you want to get in the game right now, I think you have to talk to your xPU vendor. Maybe you can buy it bundled with a server, maybe not. But you're going to be doing some of the integration yourself, and you have to pay attention to that software stack that you plan to deploy. My experience today from xPU vendors is their stacks are very immature and they're not ready to meet the needs of the larger industry.
Okay, well, we better work on that then. And when you say we, does that mean SNIA or is that OPI?
No, when I say we, it's the industry collectively, right? All of the vendors have a hat in this game. We all want to enable this new way of building clouds. The hyperscalers have done this themselves. They've built their own chips. They've invested in their own software stacks. They have big engineering teams. We need to democratize this and bring this to the rest of the industry. We need to bring it to large enterprises, telcos, private businesses. This is a technology whose time has come, but it's going to take some effort to get there.
Right. So if Amazon's done it their way, Microsoft's done it their way, and Google's doing it their way, then or Tencent and Baidu, then so we all have seen that they've shown us the wisdom of deploying xPUs. But as you're saying, we need to work on the ecosystem or the solution stack to make it easy so everyone can do it.
Right, and we don't want to see a balkanized marketplace where there's the VMware way, there's the NVIDIA way, there's 10 different ways, and you're very dependent on your one choice and you're locked into it. We'd like to see an open, common way that spreads across all of these, so you can choose, the xPU silicon card and software stack that's appropriate for you and your applications, right? And that it's an open marketplace where we have innovation and competition.
Okay, one last question for any or all of you. Is it possible that a customer might need to deploy multiple xPUs from different vendors or to perform different functions? Or is the general rule that you choose one xPU and it does everything you need?
If I jump in real quick there, I would say even if you think you chose one xPU that does everything, there's going to be a follow-on version of that, right? So there's just no way you're going to end up with a persistent, homogeneous environment. We need to be thinking about these things as heterogeneous deployments, either different versions and eras of cards from the same vendor, or literally different cards from different vendors deployed, in groups over time.
Okay, great. Amit or Mario, any thoughts on that last question?
Yeah, I definitely agree with him. I think that's something that not all xPUs will do the same. So you might need different ones to do different things, definitely different generations. Today, it's going to be very hard to deploy multiple different xPUs, but that's definitely where we should go as an industry to make it as common and as easy to do, because you would have to, going forward, deploy different kind of xPUs in the data center.
Okay, great. Hey, we are at the top of the hour, so I'd like to thank our great presenters. Tim, Amit, Mario, great job. Thank you, everyone in the audience, for attending. For those who want to see it again, remember you can watch the replay. You can download the slides, and please do give us your feedback and a rating on this webcast. Tell us how we can make these webcasts better in the future. All right, I think of course, don't forget that you can follow us at SNIA NSF. Let me see here. One more slide. It's the thank you slide. So again, thank you to our presenters. Thank you to our audience. This is John Kim, the chair of the SNIA Networking Storage Forum, saying thank you for watching. And don't forget, if you haven't seen the previous two, we do have 2 other webcasts in this series about xPUs. Feel free to go back and watch them on demand in the SNIA Educational Library or the SNIA YouTube channel. That said, if there are no other comments, I will go ahead and end the webcast. Wish everyone a good day, a good night, or a good morning, and see you on the next webcast. Hope to see you soon.